Okay, the last section from 7.6, and the first video you watched was solving exponential equations. This one is solving logarithmic equations. So you are probably okay with the fact that if I take log base b of x and say that it equals log base b of y, if the bases are the same, b and b, then you know x and y have to be the same. So looking at a simple example, if I have log base 3 of x equals log base 3 of 8, of course the only thing that makes sense for x is that it has to equal 8, otherwise those logs aren't equal. So this first example says solve log base 7 of 6x minus 16 equals log base 7 of x minus 1. So the first thing that I would probably note is that my bases are the same. They're both a base of 7. So I know whatever I'm taking the log of here has to equal whatever I'm taking the log of here, simply because their bases are the same. So because of that, I'm going to say, well then 6x minus 16 has to equal x minus 1, and obviously that becomes a very easy math problem. So I'm going to subtract x to get 5x minus 16 equals negative 1. Then I'm going to add 16 to get 15, and then x equals 3. And again, like with exponential, you want to make sure you check your answer in the original equation. So if I take log base 7 of 6 times 3 is 18, 18 minus 6 is 2. That should equal log base 7 of 3 minus 1 is 2, and certainly those equal each other. This one is just one log instead of 2, so it says log base 5 of 3x minus 8 equals 2. Remember, when you're taking the log of something in parentheses, you can't separate it. I can't divide by just the log of 5, or I can't add 8 and divide by 3 and do all that jazz, because this is all one number. So I am certainly stuck in logarithmic form. I mean, again, I could guess and check. I could put x's in, but you don't want to guess and check. You want to solve it algebraically. So like exponential equations, when you're stuck in one form, you go to the other form. So I'm stuck in logarithmic form, so I want to go to exponential form. And the process that we use is called exponentiating both sides. So if the base of my log is 5, I want to use the base of an exponent also of 5. So I'm going to exponentiate both sides, which means I'm just going to raise the entire right-hand side from a power of 5 and the entire left-hand side and the entire right-hand side, both of powers of 5. Now, when you have a base of 5 as an exponential function and a base of log, those 5s, remember, according to our inverse properties, cancel each other out, and hence I'm just left with 3x minus 8. On the right-hand side, 5 squared, well, that's easy, that's 25. So again, base of 5 raised to a log base 5 cancels out to 3x minus 8, and 5 squared is 25. And then again, it's basic algebra. So if I add 8 and divide by 3, I get 11, and then just double checking your answer in the original equation. So log base 5, 3 times 11 is 33, minus 8 is 25, and log base 5 of 25 is 2. So we're good to go. Alright, last but not least, the doozy. Log of 5x plus log of x minus 1 equals 2. And I have two logs again, but I also have a constant in there getting in my way. So if I didn't have that 2 in there, I could set these equal to each other, and it would be a basic, simple problem by dropping the logs. But unfortunately, I can't because I have it equaling 2. Notice both the logs have the same base, and I am adding them together, so I could condense these two logs into one log with the product rule since I'm adding them together. So I'm going to start there. I'm going to do log of 5x times x minus 1 equals 2, which of course is log of 5x squared minus 5x if I distribute that through. And then I'm stuck in log form. I've got down to my isolated log here, and I'm going to exponentiate both sides. Well, again, the base of log, I'm going to squeeze in a little 10 here. The base of log is 10, so I'm going to exponentiate both sides by a power of 10. So if I raise both sides from a power of 10, then 10 raised to log base 10, that cancels out to 5x squared minus 5x, and 10 squared is 100. And look at that, we have a quadratic. So I'm going to divide everything by 5 first, just to make our life easier. And then get everything to one side. So I'll subtract the 20 over. And then hopefully it's factorable. And if not, use the quadratic formula. Okay, so I'm going to do x minus 5 times x plus 4. And when you set each of those equal to 0, you get a positive 5 and a negative 4. And I need to check both of those in the original. So 5 and negative 4, I'm going to go back up here. And if I check 5, I'm going to mentally check, so follow along here. I'm checking 5 first. So log of 5 times 5 is 25, plus log of 5 minus 1 is 4. Okay, so I'm going to have log of 25 plus log of 4. And is that equal to 2? And yes, it is. So that checks. Now I'm going to erase. Oh, I can't erase it. That's all right. Now I'm going to check negative 4. Okay, so first and foremost, when I check negative 4, I'm going to have log of 5 times negative 4 is negative 20. And right there I'm going to stop. You cannot log a negative number. Think about what to the, some power is equal to a negative number. It doesn't happen. So right there I know that negative 4 does not work. However, 5 did work. So you have to make sure you check for extraneous solutions. So just to reiterate that, you cannot log a negative number. So had I checked my answer down here, I wouldn't have actually ran into that problem. That's why it's really critical to check your answers in the original and note that once you're logging a negative number, you already know that that answer is not going to work.